we said this is here in looking at volume of prism and cylinders. Volume of prism and cylinders. Remember that when you are looking for volume, you will be given the following. Capital V is for volume, equal capital B times H, where B is the base area. Capital B is the base area. Whatever the base is, you find the area of the base, where H is the height of that. This is one choice. V for volume equal capital B times H. Capital B is base area. Or the other option, you will be giving V equal capital B times H over 3, or divided by 3. As you already know, capital B is still base area. And H is the height. You have to know for which shape does it apply. So we're going to go over that. And the other option, you will have V equal 4/3 pi r cube, where r is the radius. So those are the parameters we're playing with. So you have to know for which those values may apply. So you have to know this is what you call a cylinder, a cylindrical form, right? It has the base has a circle. The base has circles, so you will have to know how to find the area of a circle, right? And the height is located between the bases, both top and bottom base is the height. So in this case, if I want to find the volume of a cylinder, I know it can apply for this. Capital B is area of the base. To find area of a circle is pi r squared times height. Therefore, this is work for a cylinder. You can use this formula to find the volume of a cylinder, right? So remember, capital B is area of the base, and the base is circle. How do you find area of a circle? Is A equal pi r squared, right? R is the radius. You square the radius with time by pi. Pi can be the pi symbol, or 22/7, or you can use the estimated, the approximate value, which is 3.4, based on what is given to you. So this formula can be used for cylinder. It can also use for a cube. Remember, a cube, it has 6 squares, 6 faces. The faces are squares. So remember, for area of the base are squares. So for a squares, the length and the width are the same. So if you were to find the volume of a cube, is the length is longer than the width, times the height, times the width, times height. In this case, the length is equal to the width is equal to the height. Therefore, when you look in the volume of a cube, is S squared, S for side, or L cube, W cube. All of these sides are the same. So you're going to cube whatever it is. For a cube, the volume of a cube is L to the 3rd power. The length is equal to the width is equal to the height. Therefore, you have to cube one of the side. S in this case stands for side. So this formula can also use for cube. You can use this formula for cube. Remember, a cube is form of 6 squares. So when you're dealing with a cube, the length of the squares is equal to the width of the squares, also is equal to the height. The dimensions are the same. So when you have volume equal capital B times height, it is applied for cylinder, it is applied for cube. And it is also can be applied for what you call a rectangular prism. So the difference between a cube and a rectangular prism, for the cube, all the dimensions are the same. The width, the height, and the length are equal. For a rectangular prism, they are not equal. The length is longer than the width, and whatever the height is. So there's a chance that the number is going to be different. Whereas for a cube, the numbers are the same. You can use this formula also for what you call a rectangular prism. Rectangular prism. Those are rectangles, 6 rectangles, or it could be some squares, but that this one is called rectangular. This is rectangle. The faces are rectangle. So when you have V volume equal capital B times H, it is applied for cylinder, it is applied for cube, it is applied for rectangular prism. Remember, for cube, the length are the same. So the length is equal to the width is equal to the height, because the faces are squares. Whereas for rectangular prism, the dimensions are not necessarily going to be the same. They are going to be different. So in this case, for the first formula, you can use those properties. It's work for cylinder, cube, and rectangular prism. So that's why you're going to match those formulas. Alright? The easiest one is what you call a sphere, a globe, a soccer ball, a baseball. This one only apply for these guys. Volume equal 4/3 pi r cube. This only work for a sphere. Therefore, if you have a sphere, you only need to know the radius. If you know the radius, you can find the volume of a sphere. So 4/3 pi r cube is work for a sphere. So you apply for sphere. Sphere is a globe, circle, soccer ball, baseball, any type of ball. That round shape, that is sphere. This can be used for a sphere. Alright? And the other one, we are continuing with our lesson on how to find volume of prisms, cylinders, and other shapes. So here, as you can see, this is what you call a cone. You can mainly use it for V equal capital B times H/3. As you know, that B is area of the base. Since you know the base is a circle, you will find area of a circle, which is pi r squared times height and over 3. This is for a cone, how you find the volume of a cone. You can use that formula. So B is area of the base, and the base of the cone is a circle. You will find the area of a circle pi r squared times h, and you divide by, you take 1/3 of that. You divide by 3. In other words, that if the radius and the height are the same, you're going to, the volume of a cylinder is 3 times as much as the volume of a cone, but the radius and the height must be the same. Or in other words, if you know the value of a cone, multiply by 2 will give you the volume of a cylinder with the same radius and with the same height. So we can use those formula also for square pyramid. So we can use that to find the volume of square pyramid. Alright, remember that if the base is a a square pyramid that the length and the width are congruent. And it can also be used for rectangular pyramid. So the base is a rectangle. So that these are the main figures. You can use that formula to find their value. And remember, volume must be expressed in cubic unit. It's 3 dimension. So when you're looking for volume, it must be expressed in cubic unit. So this is very essential. So the other option that you will face is when you have composite figures. For instance, you can have 2 cylinders, a bigger cylinder and a smaller cylinder, and then you will have to find volume of both of them. If one is on top of another, you find both volume, you add them. That will be for composite figures. However, if one is inside of another, you still find the volume of both of them, then you find their differences. Alright, look at those scenarios. If one on top of each other, you find the volume of both shapes, both cylinders, you add them. If each one is inside of the other one, you find their volumes, you find differences. This can also work if you have a cube and a cylinder, whatever the 2 shapes that you have. In this case, you will find the volume of the cylinder, alright, and volume of the cube, then you add them up. Alright, however, if the cube is inside the cylinder, you will find the volume of the cylinder and the volume of the cube, then you find the differences because the one is inside of another. If one is on top of each other, you find both volume, then you find the sum. You add both volumes, you will get that. So be aware of those scenarios. On top, composite, you find both volume, you add them up. Inside, one is inside of the other one. You find both volume, you find differences. That works for any shapes. Alright? Remember also, base area means shape of the base. In this case, capital B stands for base area. We have a cylinder. The base is a circle. How you find area of a circle? Pi r squared. So times the height, that's how you find the volume of a cylinder. That's how you find the volume of a cube. The volume of a cube is area of the base, length times width. When it's a cube, the length and the width are the same, they equal, and the height also is equal. So for a cube, the length, the width, the height are the same. So you take the volume, we take one side, you cube it. That will give you the volume. And that also works for rectangular prism. The only difference between a cube and a rectangular prism, for a cube, the faces are squared. For a rectangular prism, the faces are rectangle. The length, the width, and the height not necessarily going to be the same. Alright? So remember, for sphere, you use this sphere only for the formula that says 4/3 pi r cubed. That's how you find the volume of a sphere. So this is the only formula, that's the only shape that is worked for. 4/3 pi r cubed is only for sphere. A sphere is the globe, a ball, soccer ball, baseball, those are sphere. This is the formula that you use. Alright? For capital B, V equal capital B times H over 3. You use that for cone. For cones, you use that for square pyramid, you use that for rectangular pyramids. So this you will have to divide by 3. The only time you divide by 3 is for sphere, for cone, for square pyramid, for rectangular pyramid. The only time you don't use 3 is for cylinder, for cube, for rectangular prism. So those are the key concepts that I want to convey to you. And remember that when you're looking for volume, volume is 3D, 3 dimension. Therefore, your unit must be cubic. So whatever unit that you find, it must be cube. 3Ds, right? Cubic unit. Volume is expressed in cubic unit. Be aware of that. Let's go do some work and do some practice. Remember, composite, you add them up with one on top of each other. If one is inside of one another, you find their difference. So those are the key concepts I want to convey to you today when you're looking for volume of prism and cylinder. That was Mr. DCS in another one.